All right. So let's discuss the solutions for week 5 quiz. Because I think this is going to be the same thing as discussing the techniques, because I will go through this through examples, and it's better just to go ahead with the quiz solution. So let's do this here. Start with quiz week 5. Can you guys see my screen now?
Yes, sir.
All right, so let me do it here. So in quiz week 5, we have one question is to solve the recurrence relation an is 5an minus 1 with a0 is 5 and n is greater than or equal to 1, right? So the question was asking what's the form of a1 up to an minus 1. So a1 is simply 5, a0, right? And then a2 is 5, a1, yeah, and so on up to an minus 1, right? So you have it until an minus 1 is 5 of an minus 2, yeah, and of course an is 5 an minus 1. Now with this one is rather straightforward for not yet with the generating functions. So we could so let me shift this a little bit. Hold on a second. Yeah, so here, so we have that the solution becomes so this becomes, of course, 5 times 5 an minus 2, right? And this is, of course, which is 5 to the power of 2, yeah, an minus 2, and so on. Yeah? So for example, this becomes 5 squared times 5 an minus 3, which is, of course, then 5 cubed an minus 3, and so on, yeah, and so on until you get, of course, 5 n minus 0 a0, or 5 for n a0. Yeah, of course, in this case, this gives us actually the solution is 5 for n times 5, which is, of course, 5 power of n plus 1. So that's the solution for the first question. Now, what about the next question? So the next question is, you want to let's do it again here. Yeah. We haven't had the chance to discuss this quiz last week, so let's do it here first. Yeah. Now, what about this one? So let's now going with the second questions. So determine the number of ternary strings. Yeah, since it's consisting of the digits, consisting of the digits, digits 0, 1, and 2, right? Now, the number of ternary strings of length n that contains 0, 1. So then let's start with the defining the term, right? So let an be, of course, the number of strings, the number of ternary strings of length, and that contains 0, 1. All right. Then what is A0? What was your answer last week? What is A0 in this case? Anybody? Moza, what's your answer? What is A0? Okay. Nobody wants to answer? Nafis?
Is it 1, sir?
Why is it 1? Is it true that it is 1?
Because the number of ternary string with the length 0 is only 1, like empty string.
All right, but then let me ask a question. Does that empty string contain 0, 1?
No.
So does it mean that an is 1 or an is 0?
It's still 1.
Remember, an is the number of ternary strings of length n that contains 0, 1.
So it means 0.
Yes, it has to be 0, right? Because we define an always in terms of what we want to count. All right, not an as the number of strings, ternary strings of length n, but the number of ternary strings of length n that contains 0, 1. So it has to be the condition, it has to be the ternary strings that meet the criteria. All right, so the answer is this is 0. Yeah, let me erase this. Yeah. All right. I'm supposed to have right. It's my hands, my always slips. Let's do it here. Yeah, this one. All right. All right. So here, so that means you have this. Yeah. So what about A1? Shafiko, what do you think? How many ternary strings of length 1 that contains 0, 1?
Zero.
Sorry, can you be 0? Why 0?
Because
But how did you get 0?
because it cannot contain a 0, 1.
Oh, you
because
can.
It only has the length of 1, sir.
Correct. Yeah, that is good. Yes, nice. What about A2? Let me ask Moza then.
Yes, sir.
Yes. What about A2? How many how many ternary strings of length 2 that contains 0, 1?
One.
1, yes. How did you get 1? How did you get 1 initially?
It can only be 0, 1.
It can only be 0, 1. Yes, exactly. Thank you. Yeah. So yes, it is. So it's only 1, right? So for example, ternary strings of length 2 are 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2, and then 2, 0, 2, 1, and 2, 2. Out of this 9, only this meets the criteria, right? So that's why A2 is 1. Now let's generalize this with the case, right? So let's do it. Let's start with so you want to compute this for general AN, right? So let's divide into 2 cases, right? So case 1 is ternary strings. Oh, let me write it a slightly bit. Let me do it this way. So let's consider any ternary strings of length n that contain 0, 1. So let X be a ternary string of length n that contains 0, 1. Yeah, so yeah, let's consider that X. Then we have different cases, right? Yeah. So let's consider X could start with a 0, or could begin with a 0, could begin with a 1, could begin with a 2, right? So in this case, if it starts with a 0, then we have to consider whether the next digit is 1, right? So let's use bit string. Let's consider the bit string X that starts with a 1 or a 2, right? So in this case, so let is 1 here. X either begins with, so let me erase it, begins with either 1 or 2, right? So in that case, X is actually 1 y, and or X is 2y. Yeah. Now, yeah. So X is 2z. Let's do z, right? So X is 1y or 2z. Here, y is also ternary string. But this time of length what? Of length? Anyone? Of length what? What is the length of y? Anybody? If X, let me give an example. If X is 1, 2, 1, 0, 1, 2, then y is this part. 2, 1, 0, 1, 2. So what is the length of y? If X is of length n, then
n-1.
correct. Thank you, Matthew. Yes, n-1. Yes. So that's obvious, right? Now the question is, yeah, does y contain 0, 1? What do you think? Does y contain 0, 1?
Yes, I think.
Yes, Nafis, thank you. Yes. You said, I think. What is your, why do you guess that y contains 0, 1?
Because I think like from itinerary ternary string with length n, it must be at least one that contains 0, 1.
Right. So that's to be more precise, right? So you know that that X contains 0, 1, right? So because X contains 0, 1 and X start with 1, so then that 0, 1 part, that this 0, 1 piece here must be inside Y, right? Yes. So yes, because X contains 0, 1 and X is equal to 1Y. So the 0, 1 part or piece must be part of Y. Yeah. So the question is then, so Y is, so that means Y is a ternary string of length n minus 1 that contains 0, 1. Yeah. And then how many such Y's? How many such Y do we have? How many? How many? Nobody knows about this? Let me give you a hint. If an, the number of bit strings of length n that contains 0, 1. Now, if you want to count how many such Y's, we are counting the number of ternary strings of length n minus 1 that contains 0, 1. So how many such Y's? Anybody?
Is it n minus 1?
Yes, exactly, Nobis. Thank you. An minus. Not n minus 1, but an minus 1. Yeah. So that means for this case, we have an minus 1. Now, similarly, if X is 2Y, then again, Y is, 2Y, then Y is a ternary string of length n minus 1. Then also that contains 0, 1. Yeah. So, and therefore, there are a minus 1 such ternary strings, right? Yeah. So therefore, for case 1, if X begins, so for case 1 we have, so let me do it here, the number of ternary strings of length and that contains 0, 1 and begins with 1 or 2 is what? An minus 1 plus an minus 1, which is of course 2an minus 1, right? Now that's one case. What about the next case? The next case is second case is case 2. X begins with, X is the number, is ternary string of length, and that begins with 0. So X must be 0Y. All right. Now, but since X begins with a 0 and X also contains 0, 1, we have different possibilities, right? Yeah. Namely, yeah, namely that so we have case 2a in this case, yeah, y contains 0, 1, right? Yeah. So how many such y's? Remember, y. So here, not this here, y is a ternary string of length. Let's use z, right? So z is ternary string of length n minus 1. That's it, right? So z, now we have two cases. Z itself contains 0, 1. So z is a ternary string of length n minus 1 that contains 0, 1. So how many? There are, of course, an minus 1 such z, right? Now, case 2b, z does not contain 0, 1. Is it possible? Is it possible that z doesn't contain 0, 1? Anyone? Is it possible that z does not contain 0, 1?
Yes.
Yes. Yeah. Yes, it's possible. Then, yeah. Yeah. Then what? If z doesn't contain 0, 1, then essentially z must start with 1 actually, right? Yeah. If z does not contain 0, 1, then z must be of the form. So you know x is 0 something, and then that something here is z. You know that. Let me shift here a little bit. So x is 0, z, and you know that x contains 0, 1, but z does not contain 0, 1. So what can you conclude from here? X must be of the form what? Must be of the form. How does X look like? X starts with 0 and followed by Z. Z is a ternary string of length n minus 1. And you know that X must contain 0, 1, but Z does not contain 0, 1. So what can you conclude from there? X must be of the form 0 followed by
1.
1. Yes. Why does it have to be 1, Matthew?
Because it contains 0, x contains 0, 1, right?
What is it, Matthew?
Is it because x contains 0, 1?
Because X contains 0, 1, right? X must
Yeah.
contain 0, 1, but Z does not contain. So,
Yes.
so if I say X is equal to 0, 0 something, then X cannot contain 0, 1 because we already know this part does not contain 0, 1. Right? So, similarly, if X is 0, 2 something, right? So again, we cannot have X in that case, right? Because X must contain 0, 1. So therefore, the only choice is, of course, X must be of the form, yeah, must be of the form 0, 2, say, call it W. Sorry, 0, 1 W, right? Where W W is a ternary string of length n minus 2, right? Yeah, that can it contain 0, 1 or can it not? Can it contain 0, 1 or can it not?
No, I think not.
No. Why?
Because Z does not contain 0, 1.
Right, it does.
And the first digit of Z is 1.
Correct. So yes. Yeah. Because we already know that Z does not contain, yeah, because Z does not contain 0, 1, yeah. So therefore, how many sets W? So W, where it's 3 to the power of n minus 2 minus.
A n minus 2.
Correct. Yes. Yeah. Because this is the total number of ternary strings of length n minus 2, and this is the total. This is the number of ternary strings of length n minus 2 that contains 0, 1, right? So therefore, we have, we have that the total number of so we have totally, so an must be, from the first case we have 2an minus 1, and from case 2a we have an minus 1. From the last case 2b we have 3 to the power of n minus 2 minus an minus 2, or in other words you have that this is 3an minus 1 minus an minus 2 plus 3 of an minus 2. So let's check here. So a0 and a1 are both 0. Yeah, we know that. So what about a2? Is it correct? A2 is, of course, 3 times 0 minus 0 plus 3 times 2 minus 2, which is 1, which is correct, right? What about a3? So a3, how many ternary strings of length 3 that contains 0, 1? Well, there are 0, 1, of course, 0, 1, 0, or 1, 0, 1, or 2, 0, 1. So only 3 of them, right? Which gives us, do we have more? I think we do have more, right? So 0, 0, 1, yeah? 0, 0, 1, 0, 1, 0, and then of course 0, 1, 1, yeah? And then 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 2, yeah? And then of course, yes, and then of course 1, 0, 1, and 2, 0, 1, yeah? It has to be 6. Let's check, right? Hopefully I'm correct. So let's see. 3 times 1 minus 0 plus 3 times 3 minus 2, which is of course 6. Yeah, so we are correct. Yeah, so that's how we get the solution. Yeah, so what about the next question? Now let's have a look at the generating functions. Now in the next question, we have this part. Yeah, with this part. So here again, all right. All right, so let's see. So we have this question. Question is, given set an, which is 0, 1, 2 up to n. Yeah. So count the number of subsets of n of an, yeah, that does not contain two consecutive numbers. So before we continue, let's start with examples, right? So suppose, let's consider A3. So A3 is this, not 0, 1. Let's start with A2, right? A2 is 0, 1, 2. The subsets are, of course, empty set. Or let me do empty set, and then we have the set 0, 1, 2, and then the set 0, 1, 0, 2, 0, so 1, 2, and then of course the set 0, 1, 2. So let me ask a question: which subsets that satisfy, which subsets satisfy the criteria? The criteria must be it does not contain two consecutive numbers. Which subsets satisfy the criteria? Any guess? Anybody? Which subsets of A2 that does not contain two consecutive numbers?
Zero.
This one, the empty set.
The empty set, 0,
Yeah.
1,
this
2, and 0, 2.
0, 2, yes. Very good. So there are how many? 4 of them, right? So 4 of them. Yeah. Let me circle this. Not 4, 5 of them, sorry. 5 of them. Yeah. So now let's generalize this. So let's start with A0. So A0 is, what do you think? A0 is 1, right? Because only the empty set, right? A1 is 3, yeah, namely the empty set, the set 0, and the set 1. Yeah. What about this set? This is also a subset of A1, right? Yeah, but we exclude this because it contains two consecutive numbers. What we want is a subset that does not contain two consecutive numbers. Now let's check.
Sir,
Yes.
I think the A0 one is 2 because it's empty subset and 0.
No. If you want to look A1, then look at A1 here. The set is this one, right?
Yes, A0 is 0, right?
Oh yeah, A0
Is 0, so empty set and then subset 0, I think.
or okay. Oh, you're talking about, so let's see A0, right? So A0 is this one, right? Oh, sorry, this one.
The set with 0.
Yes. So that means the subset must be empty.
And then
So
0.
it should be 2. It has to be 2, sorry. It has to be 2, not 1, 2. A0 must be 2. Yeah, so can you guys still follow me? So why is it 2? Well, because the subset of A0 is the empty set and this set, right? And both does not contain 2 consecutive numbers, right? So therefore A0 is 2. Right. A1 is 3. Yeah, it's clear, right? A2 is 1, 2, 3, 4, 5, right? So we already saw that, right? A2 is 5. Yeah. Any question so far? Is it clear?
Yes, it's clear.
Okay. So let me just tidy this up a little bit. So A0 is actually this set, contain an integer 0. Yeah. So the subset are here. So now let's generalize this. Let's consider the set AN. Yeah. Now, case 1, a subset of AN contains. So case 1, consider and look at its subsets. Yeah. So case 1, well, let's do it this way. Yeah. So suppose let's call it B. Yeah. B is a subset of AN. Yeah. B is a subset of AN. Now, case 1. Yeah. Let me just here. So case 1. Here we have that B contains the integer n. Oh, sorry. B wrong here. Case 1 is the easier one, is B does not contain the integer n. Yeah. Yeah. How many such B's do we have? So for example, in the case of A2, the subsets are the B subsets are, you already know that these are the subset. Yeah, which is 0, 1, 0, 2, and then of course 0, 1, 2. Now, case 1 belongs to, let me color it with red. Case 1 here. Which B are we looking at? Which B? Well, has to be this one. Yeah. And then this one. And then this one. Yeah. And then this one. Right? Yeah. That's the B. That's the possible examples of B. Right? All possible examples of B. Yeah. So how many such B's? Well, this is the same as, yeah. How many such B's? Well, it's the same. It's actually, yeah, as if you fix the last number, you fix the number so that you don't contain n. Yeah. It cannot contain n. Yeah. Then there are two to the power of n minus 1 such b's. Yeah. Because of what? Because yeah, b cannot contain n, but b may contain any number from 0 to n minus 1. All right. So yeah, so there are, sorry, not 2 at the power of n minus 1, 2 to the power of n, I'm sorry. It's 3. Yeah. 2 to the power of n. Yeah. So b may contain any number from 0 to n minus 1. Yeah. So it can be, for example, in this case, b could be empty set 0 up to n minus 1, but not n, right? And then you have 0, 1, 0, 2, up to 0, n minus 1, and then you have 0, 1, 0, 1, and so on, right? So you have like all possible combinations of them, right? So 2 to the power of n. Now for the second case, b contains the consecutive numbers. Yeah. Let's see. So what about case 2? Yeah. B doesn't contain the integer n. Yeah. Sorry, B contains an integer n. Yeah. So B contains the integer n. If it contains the integer n, in order for it not to have 2 consecutive numbers, to assure that B does not contain 2 consecutive numbers, then of course B cannot contain the integer n minus 1, right? Yeah, B cannot contain the integer n minus 1. So that means then B B does not contain the integer n minus 1. So B must be of the form B is equal to, let's call it C union n minus 1, right? Where C, yeah, in this case does not contain n minus 1, but may contain any numbers from 0 to n minus 2. Yeah, so in that case, yeah, that means C is obviously C also a subset of an, yeah, that contains that contains n, the integer n minus 1 and possibly any number from 0 to n minus 2. Yeah, so for them, yeah, how many, so what is C in this case? C is actually a subset of sorry, I think I made mistakes. Do I make mistakes here? Now should be 2 to the power of n, right? So it should be B can contain n, but B contain. Oh, okay, sorry, yeah. Let me do it again here. Let me repeat then again this part. I think I make mistakes here. Let's do it again. So how many such bits do we have? B does not cannot contain the integer n. Yeah. And also, and B does not contain 2 consecutive integers or numbers. So that means how many such b's? Well, an minus 1, right? Because yeah, we take possible numbers from 0 to n minus 1 and no 2 consecutive numbers are allowed. Yeah, so n minus 1. So in this case, similarly here, B contains the integer n. Yeah, but still we have the condition, and B does not contain 2 consecutive integers. Yeah, so that means, let me repeat, in the first case, B does not contain the integer n, and because B must not contain 2 consecutive numbers, yeah, so essentially we are talking about all possible subsets we could create by taking the numbers from 0 to n minus 1. Yeah, so there are an minus 1 of them. Now what about this one? Yeah, again in this case, yeah, also C still must not contain 2 consecutive integers. Yeah, in this case, yeah, an minus 2 of them. Yeah, so therefore, yeah, so we have an is an minus 1 plus an minus 2, yeah, where a0 is 2, a1 is 3, and therefore the generating function is gz. So you start from a0, 2 plus 3z, and then for the next one, yeah, is 5z squared, and then 4z cubed plus 13z, 4 plus, and so on. Yeah. So that's the generating function. Yeah. Any question? Sorry about the mistakes. So let me repeat again. The first case, a subset does not contain the integer n, and still we have the condition that has to be satisfied, namely b does not contain two consecutive numbers, right? So an minus one of them. For the second case, we have b contains the integer n, so therefore b does not contain two consecutive numbers, and b does not contain two consecutive numbers, so therefore b cannot contain the integer n minus one, and so we could write b to be C union the set containing just a single integer n minus one, and in this case C does not contain n minus one, yeah, but may contain any number from 0 to n minus 2, and also C does not contain two consecutive integers, so an minus 2. Yeah. So we have this, and any questions so far? No? If not, so let's work on with finding the closed form of a generating function. So now let's do it here. Yeah. Yeah. Here, let's do it quickly. Now here we have a sequence 5, 15, 45, 135, 405, and 1215, and so on. So the generating function is, of course, of the form. Just write it down, right? So 5 plus 15z plus 45z squared plus 135z cubed plus 405z for 4 plus 112, 1215 z of 5, 5, and so on. Yeah. So, and therefore, now, how do we solve this? So we do it by looking at this form. Yeah. Let's see. Here we have 5. You could take the 5 out, or let's see what is the common factor of this. They're all divided by 5. But also, let's do it this way, right? So we have GZ is of course 5 times hold on a second. So if looking at this, yeah, it is a geometric, right? So geometric series with ratio between an and an minus 1 with ratio 3. Yeah. So therefore, we could simply multiply them by 3. So for example, 3 times GZ gives us 15 plus 45Z plus 135Z squared plus 405Z cube, and then 4 and so on. Yeah. So now you see that this is actually now if we multiply this by Z, so you have 3Z times GZ is of course 15Z plus 45Z plus 45Z squared plus 405Z cubed plus 12, 15, C4, and so on, right? Now that is actually something that we could do, right? So you take this and you take this. If you subtract GZ minus 3Z GZ is what? Is of course, what do you get if you you subtract this line against this line? What do you get? Amar? Anybody? What do you get?
5.
5. Yes, exactly. That's just 5. Yeah. So now with that, we could simply factorize the left hand side. So you have 1 minus 3Z times GZ, yeah, is 5. Yeah. So therefore, GZ is, what is it? Well, 5 over 1 minus 3Z. Yeah. Good. So that's question number 4, I think. Okay, so we have different cases, right? So another number of cases, let's use this form. Now, so the question is this one. It was question, one possible questions. Yeah. Let's do it here. So next question is GZ is 5 plus 5Z plus 5Z square plus, no, this is the tricky part, Z over 1 minus 3Z square. Now, how do we solve this?
Divided to 2 parts.
Divided into 2 parts, yes, exactly. So we take it this. We do this. And then this one is by itself. Yes. What do we have here? This part represents the sequence of 5, 5, and 5, and 0, and 0, and 0, and so on. Yeah. What about this one? Z over 1 minus 3Z square. Suppose this is actually, call it FZ. Yeah. Then where FZ is, call it A0 plus A1Z plus A2Z square plus A3Z cube and so on. Yeah. Or let me write down, this is actually the sum of n from 0 to, so I from 0 to infinity, so n0 to infinity, and z to the power of 1. Yeah. So therefore, z is equal to 1 minus 3z square times fz, which is 1 minus 3z square of sum of an from 0 to infinity z of n, right? Now in this case, yeah, we have that therefore the right hand side is actually 1 second. Yeah, the right hand side is actually sum of n from 0 to infinity an z to the power of n. This is one part. So you multiply them, 1 multiplied by this, and then minus 3z square, yeah, times of sum from m0 to infinity n z of n. Yeah. Now, this is of course fz itself, right? So fz itself. Oh, hold on a second. We know that this is fz, yeah. So let's just do it. So this is, yeah. So this is sum of n from 0 to infinity. Z is this, and z to the power of n minus sum from n from 0 to infinity an times 3 times c to the power of n plus 2. Yeah. So let's have a look at this. Yeah. So we have essentially the right hand side is sum of n from 0 to infinity an times so minus hold on a second. Z square oh yeah, so forgot about this. So the next step is of course to n z to the power of n minus sum of n from, so you see the z is n plus 2. So the start, so this is essentially a0 plus a 3a0 plus 3a, sorry, 3a0 z square plus 3a1 z cube and so on, right? So if we take this, so if we go, if start from 2, yeah, to infinity, yeah, this is a n minus 2, yeah, times 3 times z power of n. Yeah. So we shift the index like that. So it's the same thing again. Yeah. So 3an 3an minus 2, yeah, times z power of n, right? So that means, yeah, excuse me, apologize. Oops. Mati lampu ya?